Okay, let's solve today's LeetCode problem. We're given the side view of a box and we have to rotate this box 90 degrees. Inside the box we have stones, these blue ones. We have empty spaces and the fixed stationary points. These are the obstacles that will not change their places. So what we have to do is to rotate this box 90 degree clockwise. You can see we're given this box, and when after we rotate it, we get this box. Basically, the stone here goes down to this empty cell, and it becomes that. You can kind of like visualize this in your mind. And the stones look the same. They do not change their horizontal position. We're not concerned about that. And then we're given this box here. Now in this box we have two different cells. The cells are fixed. They will not go down once we rotate this box 90 degrees. So this fixed box kind of becomes the end of the box, here. Like you see, when a stone goes down, it will stop when it reach another stone or the bottom of the box or a fixed point like that. It will stop once it hits one of this. So in this case, this stone, when we rotate it, it will hit this point, this cell, and stop like this one here. So we have to solve this problem. Now let's see how we can solve it. Okay, now let's analyze what happens when we rotate this box 90 degrees clockwise. Let's look at this row here. What happens, this row ends up being this row here when we rotate it, this column here. You can see when we start here at the bottom of the box, this is going to be, this cell is going to be this cell, right? This is an empty cell. So there is a case that it could have a stone at the end. Now we mark it as a place, a potential place. Let's call it I for now. Like this, we say that okay, this is an empty space. We have seen an empty space. Now let's move to the left. Now we see a stone. Now since we see a stone and we know that we had a space, an empty space, we can push this stone down to that space here. So what we do, we just take this stone instead of this. Now we'll have an empty space in place of the stone, and the stone itself goes here. Let's say the stone goes here. Now our new marked place, basically we mark this place as the new empty space. Now we move to here. Now we have another empty space, but since we have an empty space, we don't do anything. This is just two consecutive empty spaces. Every stone will just go through this empty space and to the next empty space, where we mark the I. So basically I is, if we have an consecutive empty spaces, the I is the rightmost one. So it marked the rightmost one. This, you can imagine this as rotated. Once it rotated, this empty space, so this I is here. Now everything above, let's say there is a stone, it will pass through all of this consecutive empty spaces down right here. And if there was a stone, it will end up at this point. And then our I becomes this, the new empty space. Okay, now let's look at this next space. This is an empty space. Then we move to here. Now at this point, we have a stone. Now our stone now goes to this point here, which is an empty space. It goes into this cell. Now we'll have an empty space instead of it, and this is going to be a stone. Right, now we move our empty space, the marker of empty space, to the next space. Now we don't have this two. Now we move to this one. Now here we have another stone. This stone will move to this space. This moves here. Then we move I to the next stone. So this is going to be the next place. So then we have this one here. It's a stone. Then we move it down here. Now we have 4 stones in a row, just like then when we rotate this stone ends up being here, this stone is here, and this stone is here. So you can see the 4 of the stones, it's here, and then we have also we move this here, so then we have an empty space in place of this. So this has 2 empty spaces. Now let's look at another case, because this row did not have this fixed obstacle. Let's see how we can handle it. Okay, let's start with the second row. We have an empty space, that's fine. So we say, okay, let's mark it. So this isn't the start of an empty space. Then we move to this is an empty space. We move to the next empty space. This is an empty space, so we don't do anything. We already have an empty space. We move to an obstacle now. We run into an obstacle. This is a fixed obstacle. That means everything to its left, so basically it will be everything to above above of this stone when we rotate it. Everything here will not pass through this obstacle. They will be prevented. They can't go down to this empty spaces. So we have to reflect that in our marker case. So we have this marker, right? Then we say, okay, this is an obstacle, so let's set the marker to -1 or something like that. So just to denote that we do not have a space yet. We haven't just started. We do not have an empty space, so the stones can move there. Then we say that, okay, now we don't have this pointer, so we just move to the next stone. When we move to the next stone, you can see if we had the marker here, since we don't have, we move this one freely to this space, but we do not have, so it just stays where it is. So then we move to the next stone. So we move to this stone. Again, we do not have any free cell, so it stays where it is. Then lastly, we move here, and again, we do not have any space, and it stays where it is. So now let's look at this row here. This is going to be the same thing. We mark it as the beginning of an empty cell. Then we run into an obstacle. Then we set it to -1. So just to denote that we do not have yet any empty space. Then we again run into an empty space. Then we set I here, and then we run into an obstacle. Then we set that, okay, we do not have an obstacle again, any free space again. Then we move to this. When we move to these 2 stones, they will just will be fixed in their places. They will not move down the box. So at the end, we'll end up with this one. So basically, what we did is to go from right to left, and this corresponds to bottom to top. When we go right to left, we say, okay, there is an empty space, and then immediately we run into either an empty space. After an empty space, we immediately run into an empty space or a stone. If it's a stone, we'll just move this stone all the way down to the first empty space, just like this one here, right? Then we did that. We have two empty spaces. Then when we reach this stone, it will move all the way down to this empty space. So that's what we did. And when we reach a fixed point, right, this one here, this means nothing above can now pass to this cells here. Even if we had these 2 empty cells, if this was an empty cell, then this would just go down to the bottom, and this would go down to the top of this stone, and this would go down to the top of this stone. But since we have this obstacle and it is fixed, so this stone will just stay where it is, and this stone will stay it is, because there is another stone and this is also fixed in its place. So that's how we handle these 2 cases. When we have an obstacle, we just said that, okay, we don't have any empty space yet because we run into an obstacle. So let's see actually another case. Okay, this is the example 2. Now let's start for the first row. we mark this as the empty space. Then we immediately run into an obstacle, and then we set I to -1, just to denote that we do not have an I yet. Then we move into an empty space. Then we say, okay, this is the beginning of an empty space. So then we mark our I, so our pointer here. Then we move to a stone. Now the stone, since we have an empty space, this stone can move down to this I here. So that basically moves here. We're gonna have a store, and we're gonna have an empty space instead of the stone. And for the bottom row, we mark this as I, then I. So then we move, then we see an obstacle, then we do not have an I, then we move to a stone. This stone, since we don't have an empty space, so it stays where it is. And then we move to the next stone. We still don't have an empty space, and it stays where it is. So this is going to be at the end stone and stone. And then we rotate. This is going to be empty since we move this stone down to here, and it is immediately prevented by this obstacle. Now let's see the code. Okay, down here we have this for loop. This basically goes through every row, and from the right of the row we have an R. This R basically represents our I when I explain. This is the marker for the empty space. We first initialize as -1 since we haven't found any. Then we start from the right of the current row, and this J is freely moved to the left. It just every time move one cell to the left. Then if we see the current cell, if the current cell is an obstacle, then if it's an obstacle, we set our current, if we had an empty space, then basically we set the marker of empty space to -1, still to denote that we don't have any. Otherwise, we check if the current cell is a stone. If it is a stone, then we check if we have any space, any free space, if the marker is valid. So if it is not -1, then yes, we have an empty space. It's either immediately after this stone, or somewhere down, or we have a consecutive empty cells, and we have to move this current stone down to the rightmost cell. So when we set the current cell as empty, and the marker and where we have the empty space as the stone, and then we move our marker to the left. So now we have either an empty space, and so we always run into an empty space when we do that. And if this was not the case, if we didn't have a stone, and an obstacle, it's an empty space. If it's an empty space, we will only update our marker if we haven't have one empty space. Otherwise, we wouldn't. For example, if we have seen an empty space and the next one is also an empty space, then we don't have to set the marker to the new empty space, because we want the rightmost one where any potential stone will end up being. So we don't have to set it. We only set it if we haven't seen any empty space. And then we create the new box. After that, it's going to be n by m. The previous box was m by n. It's going to be n by n, and we go through every row and every column of the original box. The cell, whatever we have at the cell ij, it's not going to be end up in the cell j m-1 n-i-1. You can just figure out this with a little bit of math, and then you return the new box. You can see it is pretty efficient, and we could have get away with this one, this new box here. Maybe we can do it something in place, but it still works. The main idea was here. Yeah, that is all for this problem. See you in the next videos.